down. So we're looking when, just simply put when we're looking forward when dy dt equals 0. We want to know what time that is, right? So we know that what dy dt is what? 3.6 minus 9.8t is equal to what? 0. So we're going to end up with t is equal to 3.6 over 9.8, which is what?
0.367.
Point what?
367.
367. Nice.
35.
So that's, hold on, is it 0.367? What is the answer to this?
The answer is actually the height.
I understand. So for this part, before we got to the final answer of A, what's the exact time?
0.367.
God, 0.35. So let's, since we haven't plugged this in yet to anything, let's just keep it like this, which is totally fine. Because it's asking, have we answered what it's asking you yet? No, it's not. What is it asking?
Vertical distance.
It's asking find the maximum vertical distance from the water surface of the diver's shoulder. So how do we do that? Hold on. Say that again. Yes.
You have to plug it into the antiderivative of dy dt.
Exactly. So dy dt is the rate of change of the height, correct?
Yes,
so you're integrating, if you integrate y prime t, which is dy dt, right? From time 0 to what? Let's call that time, I don't know, b, like this. dt, like that.
Yeah.
If you integrate that, that's going to be the overall net change in height from the launching time to the time at which the person is at the highest point, correct? So when you do this integral, can you tell me what this integral comes out to be when you do this? Did anybody do this? Okay, so this is where, right, divided by what? 9.8, correct? I'm going to store that as alpha b. If you round now, if you were to round this now and integrate, what's a really big danger?
They may come out to be different.
It might change the decimal place on the final answer. You can't round until the end on these. So you do this. I'm going to store it as b. STO in the bottom left, you just hit store, and a little arrow comes up, and you can store it as any letter you want. Now, Tori, whenever I type b, look what comes up. That decimal. So that allows me to just use that decimal without typing it out. So I have the function I want to integrate as my y1. How do I integrate that function? What do I press? Anybody remember? Math. And which one is it?
9.
It's math 9. And look, if you have math, if you're upgraded appropriately, you can just you can do the natural type, right? And what are we doing it from 0 to what?
B.
And you can literally do b right there, right? And then if you have the nice one set up, I think it's, what is it? It's second. You can do y1. I'm just trying to remember the shortcut. Yeah, you can. I think it's yeah. So the direct way to the normal way to do it is you go to vars, y vars, function y1. Oh, and I just overwrote it. Great. So what was that again? Math 9. I'm going from 0 to what? B.
I don't understand why we need to do it twice. Why can't we just type the equation?
As long as you have it. Oh, you'll notice. So then you just go plus 11.4. So this right here is your answer, but what do you need to state as your answer? Because you need to go to 3 decimal places. So you're very explicit. You say 12 point what? 061. And let's just check to see if that matches. Oh, look. There it is. So how did we do if we were to grade this based on, this is 3 points right here. How did we do? I think we did pretty well. So you get 1 point for considering, you have to find the time, right? Then you have to integrate, and then you get 1 point for the answer. This is 3 points. This is 1/3 of the entire question. So Tori, shoulder, enter the water. So how do you do that? That happens when what is true? When what is true?
When your changing height is negative.
Well,
100.4.
No. When what is equal to 0? Yes. This is find the time. So we want to know t when y is equal to what? 0. Yes.
So the integral of the integral of the person's I guess the velocity.
Yes. So d of the vertical
velocity.
Yes.
Is going to be the displacement, which will be negative 11.4.
You needed 11.4 because overall the person needs to go down how much?
By 11.
Correct.
Negative 11.4.
Correct. So y prime t dt has equaled to what? Negative 11.4.
Yeah, exactly.
So what do you do on that? How do you go about solving this?
We have
you know what the integral is, right?
Yeah.
Because because it's a really simple vertical what is it? It's
Three lines.
It's 3.6t, right?
Minus
Yeah.
that.
Minus 4.
So it's going to be 3.6t minus 4.9. Hey, does that look familiar? Maybe.
Yeah.
Squared, right? From what to what?
0 to x.
From 0 to n. I'm going to call it n because n. Let's say n is the time it hits the water. Has to equal what?
Negative 100.
Negative 11.4. Now, what's nice is that you're plugging in 0. When you plug in 0, what do you get?
That's 0, so just.
Yeah, so you end up with 3.6n minus 4.9n squared is equal to negative 11.4, and then you have a quadratic that you solve for n.
And that's
What is that going to be?
1.93.
1.93, what, 6?
Along a line.
So you're doing
along a curve.
a curve, right? So you're like, it's like this, right?
Yeah. So it's going to be the integral of
Yeah, what?
dy dt squared.
Yeah,
plus
it's dx dt.
squared.
Isn't it square rooted, right? It's like,
Yeah, the square
so
root
it's
of those.
0 to what? 1.9. We found the time, right? 936?
Yeah.
Of what? The square root of?
Dy dt squared.
Like this?
And then dx dt squared.
Like this, right? This is just something you have to remember, right? dt, like this. And again, you have to remember that. You have to remember that. Here's the reason that is the line integral. It's one easy way to remember it, is the fact that if you want, Jesse, if you want to estimate the distance between those 2 points, what's a really easy way to estimate that distance? Using the what? A straight line, right?
Yeah.
But how do you find the distance on a straight line?
Squares.
Exactly. So this little base here, that's going to be x prime t, right? And what's this going to be? Some infinitesimal. So how do you find the distance between those 2 points? The square root of the 2. Having an equation in parametric form makes it really easy to find the arc length or the path, the distance traveled. It's one of the pluses. If you have it in Cartesian, it's a little harder. Yeah, you need to separate it into parametric and use this. So in this case, again, do you get any bonus points for doing this by hand? No. It's very possible that this is a pain in the butt, if not impossible, for you to do by hand, right? So what do you have to use? Right there. So there it is. There's the distance traveled. And then the last, see what it looks like in totally clean format, because I always like doing this. Look, dx, oh look, it gives you that. So how do you find it? You tan inverse. And then 2 points for that one. There you go. A, it says, let f be a function and is twice differentiable. Nice. The table will give values of f for selected points from 2 to 30. Nice. Estimate f prime of 4. In this case, I'm guessing, just correct me if I'm wrong, did you do like 5 minus 3 over negative 2 minus 4?
Yeah.
Is that what you got?
It was the other way around. Yeah.
Oh, did I just invert my slope?
That was echo.
Nice. See? I'm really good at this game. Negative 2 minus 4 over 5 minus 3. Is that better?
Yeah, exactly.
So you end up with negative 6 over 2. So it's what?
Negative.
Great. Okay. So then it says evaluate that integral. What should you do for this one before you actually? What should you do for b?
Just separating.
Separate it out, right? So you have the integral from 2 to 13 of 3 dx, right? Minus 5 times the integral from 2 to 13 of what? F prime x dx, like this. Okay. So what is this?
3x from
3x. It's
39 minus 6.
Yeah, it's going to be 39 minus 6. Do you agree with that?
Yeah.
Okay, so then how do you go about doing this one? This is going to be minus 5 times what?
F of 13.
That's the f of 13 minus f of 2.
13 minus f of 2. Do we have estimates for both of those?
Yeah.
Yeah, what's f of 2?
1.
1. And what's f of 13?
6.
6. So can you do this directly from the chart?
Yes.
Yeah.
So does that? It's kind of nice. And they're setting you up. This is an interpretive question, right? So it's going to be 25 to 8. Is that what you got? Does that kind of make sense? Okay, just making sure. You do the left endpoints, right? What I like to do, because I always get confused at what I'm looking at, I like to plot the points. We have 2, 3, 5, 8, and what? 13. So it's 2, 1. There's the point 2, 1, right? What's 3 at? 3 is at what? 4? 4, and then 5 is at minus 2, and then 8 is at 3, and then 13 is all the way up here at what? 6. So how do you go about using left-hand ones?
You always pick the left hand points.
You always go from the left hand. So what is it, like this box right here?
Yeah.
Right there? And then it's going to be that box, and then it's going to be that box, and then it's going to be this box, and then it stops, right? So there's 4 boxes. You don't actually use that 6, right? You would use the 6 if you were to use what?
Right.
Right hand. So you're just doing the integral, which is displacement, right? It's not the absolute value. So when you do these, what do you end up with for, you end up with what? 1 right here is the area right there. 4. Oh, it's 8, right? Thank you for that catch. That is 8. You're absolutely right. And then that was 3 times negative 2 is what? Negative 6. And then it's going to be 5 times 3 is what? 15. So these are not relative, right? Because it jumps from, it's 5 difference right here. So then you add them all up, and what do you get? Like 2, 3, 18? 18? Nice. Okay, so we're happy with this, we're happy with this, we're happy with this. Nice. I'm curious, how many? The derivative at 5 is 3, right? So we know that this slope right here is what? Y equals 3, correct? Okay, so use the line tangent to the graph at f at x equals 5 to show that it has to be less than 4. How do you do that? Well, where is x equals 7? X equals 7 is somewhere over here. Let's just say it's right here. The definition of concave down means that all the tangent lines are above. It means all the tangent lines are above the actual function. So no matter where you took the tangent line in this interval, it will be above the function for all values except where it is tangent, right?
How do you explain that?
You can just say that. You can just say that. So what that means is this line right here, this tangent line, is always going to be above the function from 5 to 8 because it's concave down from 5 to 8, right? So what do we know the slope is at that point? The slope is 3, right? What's the point at that point? 5 comma what? 5 comma, oh look, 5 comma what? It tells us, right? It's 5 comma what? Negative 2. So what's the equation of the tangent line? Y minus negative 2 is equal to 3 times x minus what? 5. So y plus 2 is equal to 3 times x minus 5. That is the equation of that tangent line. Do you agree? That tangent line has to be above the function wherever it goes from 5 to 8 because it is concave down from 5 to 8, right? So if you want to plug in 7 for what is it, x value?
Yeah.
Y plus 2 is equal to 3 times 7 minus 5, right? Again, I could be totally doing this wrong. 3 times 2, right? So y
equals 4.
plus 2 is equal to 6. So y is equal to 4. What did we show? The tangent line is equal to. So to show that f of 7 is less than or equal to 4. So there's a limit. So you have this line. This is the secant line from x equals 5 to x equals 7 right there. Does that make sense? So what does the slope of the secant line tell you? The slope of the secant line is something. It's the average rate of change. So this m value right there is the average rate of change from what to what?
From 5 to 7.
From 5 to 7. So theoretically, can we find, does it give us the 7 on this one?
No, but it's asking.
Hold on, one at a time. Jesse, go ahead.
Can we go from 5 to 8?
Oh, I'm sorry.
Because 7 would be above 8.
You're absolutely correct. I'm sorry. Good, because look what it tells us. It tells us to use the secant line from 5 to 8, not 5 to 7. You're absolutely correct. Keep in mind that I'm just putting 8. I just drew this off the cuff. I didn't correlate this to any scale. The secant line from 5 to 8, like this. So can we find the slope of that secant line? So that m value is going to be the output at 8. What is the output at 8? Do we have a table right here? Yeah, the output at 8 is 3. And the output at 5 is negative 2. So what's the slope of that secant line going to be? It's going to be 3 minus negative 2 over 8 minus 5. Sorry, did I do this right?
Yeah.
Yeah, this is the output at 8 right here. This is the output at 5. So the slope of the secant line is 5 over 3. So the average rate of change from here to here is that, correct? So what do we know since it's concave down? What that means is the secant line is going to be below all of the points between.
Yeah.
Because it's concave down, is there any way to get from here to here, have it be concave down, and for it to be below this?
No.
No, it's not. If you started here, and you know it's going up, is there any way that it's concave down the entire time? It's going to be above the entire time. So what can we do?
Just make a line and then
we find the equation of this line, right? So look, the idea is here we're showing essentially that this line right here is going to be below that output right there, which is where x equals 7. So how do we find the equation of that line? Well, we know the starting point, right? What was it? Our starting point was 5, negative 2. So what's the equation going to be? Y plus 2 is equal to 5/3 times x minus what?
2.
5, minus 5, right? It's y minus negative 2, so it's y plus 2. So then what are we plugging into this?
7.
7. So you get y is equal to negative 2 equal plus, I can almost do math, plus 5/3 times 7 minus 5. So you have y is equal to negative 2 plus, 10/3, correct?
Yeah.
So you got, how many thirds? You got 6, so what, 4/3, right?
Yeah, exactly.
And that's exactly what we needed. We know that that value has to be the lowest, has to be the lower bound because everything is above it. Just kind of clear up a few things?
Yep.
Yeah, asking you to do. Hey,
Substitute.
substitute. So what do you end up with? So e to the x minus 1 squared is going to be what? 1 plus
X minus 1
x minus 1 what?
squared.
Squared plus
X minus 1
to the, yeah, squared over 2 plus. Now it says, look, write the first 4 non-zero terms. I think I was just, so the next one is what? X minus 1 squared to the what power?
6.
Over 6. And then you have to write the general term. That's 1 point here. So what is it going to be? X minus 1 squared to the n over n factorial. You have to write that because on the grading sheet, this is word 2. You get 1 point for the first 4 and 1 point for the general term. Take the easy. Take the easy.
Yep. Mr. Stewart, do I have to keep going?
No, this is what it asks you for.
I mean, like,
So what do you end up getting? You end up, this ends up dropping, so you end up with, hold on, I gotta get the right one. You get x, sorry. The 1 goes away, right?
yeah.
So you end up with x minus 1 squared over x minus 1 squared, right? And then you end up with x minus 1 squared over 2 times x minus 1 squared. What am I just doing? I'm just taking x minus 1 squared and placing it here, right? So I'm not going to write out this entire line, but what are you going to end up with if you just do this out?
1.
You're going to end up with 1 plus
X minus
1
over 2.
over 2, right?
Yeah.
Plus x minus 1 to the
Square.
fourth over
6.
6. Because 3 times 2 is 6, and then you subtract 2 from the power. You're dividing. Careful! And does it ask for the general term and the first 4? Oh, you got to keep going, right? So it's going to be to the 8, so it's going to be x minus 1 to the 6 over what?
8.
Oh, come on.
It's 8 over 2.
2 factorial, 3 factorial. What's 4 factorial?
24.
24. Thank you. Right? So then what's the next one going to be? It's going to be x minus 1 to the 2n minus 2 all over what? It's just n factorial. It doesn't change anything down there. There it is. Because you're dividing by a fraction over x minus 1 to the what? 2n minus 2, right? So when you have n and n plus 1, what does that become? Yeah, this goes away, and the factorial goes away, right? Correct?
Yeah.
So then you just have to be really careful about what you do right here, right? Just be super careful. You know, I'm like, there's too many of these things. It's going to be x minus 1 to the 2n plus 2 minus 2. That's what this is, right?
Yeah.
So what happens there? Those go away, right? And what are you left with on the bottom here? You're left with n plus 1 times what? X minus 1 to the what? 2n minus 2, correct?
Yeah.
So when you do the subtraction here for the powers, we're not done yet, right? Because we go to 25, or it's, 15. So we're done right now, sorry. So this right here, in this, what do you do with the powers? You subtract them, right? So you're going to end up with x minus 1 to the what power?
2.
2 all over what?
N plus 1.
N plus 1. Now here's the thing. So now we're looking at the limit as, not x, n. So the limit as n goes to Infinity of the absolute value of this thing, right? Now, what do you know as n goes to infinity of this thing? What's it going to go to 0, regardless of what?
X.
Regardless of x, right? Because if you pick an x value, can you always get bigger than any chosen x value? Yeah, so don't